So this thing called vector projections. You'll recall we said any vector, we can break it up into components. And when we did that, we rewrote it as, we didn't call it this at the time, but what we did was we rewrote it as a projection of that vector onto the x and the y axis. So there was P, let's say its magnitude is 2, and the direction or the angle that it makes there is 30 degrees. So if I was to project that vector onto the x-axis, so basically just means drop a perpendicular. How long would be the shadow of the vector on the x-axis? And so we could use a bit of trig and say, oh, well, that's going to be 2 cos 30, which is the square root of 3. So the horizontal component of OP turned out to be root 3i. And then vertically we could do the same. We'll drop I'm saying drop a horizontal. Can you drop a horizontal? Slide a horizontal, whatever the word is for that. But it hits the y-axis. And again, we can do a bit of trig. And that would be just 1. 2 cos 60 is 1. So the vertical component of OP is simply j, the unit vector j. And so then we know we can write OP as root 3i plus j. We chose horizontal and vertical because it's nice and convenient. We're used to working with that. But there's no reason why we have to. So say I've got this vector u and I want to project it onto the vector v. Well, same idea. I'll drop the perpendiculars from the endpoints. And that shadow that it creates, there's the projection of the vector onto v. Now, if I want to work out the length, I can draw the parallel line from the tail of that vector. Again, we could use some Pythagoras to work out that the length of that would end up being whatever the magnitude of u is times the cosine of theta. And then we simply multiply it by the unit vector in the direction of v. So when we dropped it to the horizontal, we multiplied it by I. That was the unit vector in the direction of I. Well, the unit vector in the direction of v is not as simple as just saying times v. You remember, it's v with a caret on the top. So the projection of u on v is magnitude of u cos theta times the unit vector in the direction of v. All right, now we know that u dot v is magnitude of u times magnitude of v cosine theta. Therefore, the magnitude of u cos theta is u dot v over the magnitude of v. Just rearranging that dot product formula. Okay, we said the projection, and here's the notation of it if you like, proj for projection, of u on the vector v. So v is like the subscript there. So we said it was u dot v divided by the magnitude of v times the unit vector in the direction of v. Well, the unit vector in the direction of v would be v divided by the magnitude of v. So that's u dot v over the magnitude of v squared times v. And the magnitude of v squared is v dot v. So look at this very interesting formula there. We get u dot v over v dot v times v. The mistake people would make now is to go and say, oh, well, hang on a sec, I'll just cancel this v with this v. Can't do it. Okay? Remember, you can only cancel inverse operations. V dot v is not saying v times v. It's the dot product. So therefore I can't cancel it with the times v. They're not inverses of each other. So it looks like something we should do, but we can't. Same with the top and the bottom there. I can't cancel that dot v with the dot v on the bottom. So we get u dot v on v dot v times v. And a couple of notes about that. If we were multiplying by scalars, the projection of lambda times u would be the same as lambda times the projection of u. And the addition, we can do them separately. So the projection of u plus v would be the same as the projection of u plus the projection of v. So let's find the length if I was going to project A onto B. All right, let me work out A dot B on the magnitude of B. So remember, this is just saying find the length. So it's not saying what is the projection, it's just the length. So I have 5 times 3 plus minus 1 times 4 over square root of 3 squared plus 4 squared, and so it's 11 on 5. Whereas if they were to ask me what is the actual projection of u on v, so the projection of u on v would be the length times the vector that I'm projecting it onto. And when I do all that calculation, the numbers aren't quite that nice. So we get 38 on 13 I minus 57 on 13 j. It's just minus 2 squared plus 3 squared. Because the formula u dot v over which one we're projecting onto, v. v dot v. So it's the magnitude squared. It's the magnitude squared. All right, let's play around with 8e.